fourth graders. Today in math, we're going to continue working on multiplying a fraction by a whole number, but we're going to take it one step further and be solving word problems. Now, before we get started, I want to point out one key word that you often see in word problems that have fractions in them, and that key word is the word of. When you see the word of in a word problem with a fraction, usually that means it's telling you that you're going to need to multiply. So in a lot of these word problems today, you're going to see that word of. So just remember, of means to multiply. Now I want to review a couple of the strategies that we've talked about when you're multiplying a whole number by a fraction. You can always do repeated addition. That works really well. But in a lot of these problems, you might find that the answer that you get is an improper fraction, where the top number is larger than the bottom. So some of these problems, it might be easier even to just draw a picture to help you find the answer. So let's take a look at question number 1 and try a couple different strategies to see which one works best for this problem. Question 1 says there were 6 boys running in a relay race. If each boy ran half of a lap around the track, how many total laps did they run? So if I were to just use repeated addition, I could add 1/2 6 times. When you add all of those together, you're going to come up with the fraction of 6/2. And for the answer to this question, the boys ran 6/2 laps around the track. That doesn't really make sense. Now, of course, you can turn this improper fraction into a whole number. What that means is you're taking the top number, 6, and you're breaking it into equal groups of 2. So how many times does 2 fit into 6? So there's 2, 4, 6. So if each of my whole has 2 equal parts, and I have a total of 6 parts, then that would be my answer. So that means that I would end up having 3 wholes, or the boys ran 3 laps around the track. So this is one strategy, but I realize that turning an improper fraction into a whole number can be a little bit tricky. Let's try a different strategy instead. All right, instead of adding 1/2 6 times and coming out with that improper fraction, let's just try drawing a picture and seeing how that works. So I'm going to draw half a lap around the track, so that would be one boy running, and then the other half a lap around the track. So between 2 boys, they've run 1 lap. Then 2 more boys ran a second lap, and then 2 more boys ran a third lap. So here I can clearly see the 6 runners, runner 1, 2, 3, 4, 5, and 6. So my 6 runners all together ran a total of 3 laps. Now for me, drawing a picture for this problem was quite a bit easier and quicker than doing the repeated addition, but you can choose whichever strategy makes the most sense to you. The important part is just making sure that your answer is a clear answer to the question. So here it wants to know how many total laps did they run. The boys ran a total of 3 laps around the track. All right, so that is my example for question 1. Like I said, you can use whichever strategy makes the most sense to you, but you need to make sure that the answer that you're getting is a clear answer to the question that's being asked. Go ahead, pause the video now, and then you can come on back and we'll go over the rest of the answers together. All right, here I have question number 2. Mia rides her bicycle 2/8 of a mile each day. If she rides her bike every day for 5 days, how far will she ride her bicycle? For this problem, I'm feeling like it would be kind of tricky to draw a picture to represent it, so I think I'm going to try repeated addition instead. So I'm going to do 2/8 plus 2/8 5 times. All right, when I add all of these together, I'm going to get 10/8. So I could say that Mia rode 10/8 miles, or you could always figure out that 10/8 is the same as 1 whole and 2/8 miles. So there's our answer for number 2. Let's take a look at number 3. Logan used 1/3 cup of sugar when cooking 1 loaf of bread. How many cups of sugar will he need if he makes 5 loaves of bread? So again, on this problem, we could do repeated addition. You could draw a picture to show 1/3 5 times. I think for this problem, I'm going to use the new strategy that I showed you yesterday. And the strategy that I showed you yesterday, I multiplied my whole number by my fraction by just multiplying across. In order to do that, I needed to put the whole number 5 over 1, and then you can just multiply across. So 5 times 1 equals 5, and 1 times 3 equals 3. So he would need 5/3 cups of sugar, or that's the same as saying 1 2/3 cups of sugar. Emily grew 1/4 of an inch in 1 month. If she continues to grow at that rate, how much will she grow in 3 months? Whichever strategy works the best for you is going to work to solve this problem. I think I'm going to do multiplication on this one again. So 3 months times 1/4 of an inch. I'm going to put 3 over 1, and I'll multiply across. 3 times 1 equals 3. 1 times 4 equals 4. So she grew 3/4 inches. The next question, number 5. Mia reads for 3/4 of an hour each day. How much will she read in 7 days? If I were to multiply, I could do 7 times 3/4. When I multiply across, 7 times 3 equals 21. 1 times 4 equals 4. So you could say 21 over 4 hours, but that's a really unclear number. So for this one, I'm going to draw a picture to figure out how many hours she's actually read in all. So to figure that out, I'm going to draw holes that are broken into 4 equal parts, and I need to have a total of 21 parts. So there's 4, 8, 12, 16, 20. All right, so 4, 8, 12, 16, 20, and 21. So I can see that she read 1, 2, 3, 4, 5, and 1/4 hours. So Mia read for 5 and 1/4 hours. Question number 6. Jackson made a picture that was 5/6 feet long. Chloe made a picture that was 2 times longer than Jackson. How long was Chloe's picture? So on this problem, I just need to double how long Jackson's picture was. So I could do 5/6 plus 5/6, or 5/6 times 2. I'm going to put my whole number over 1, and I'll multiply across. That'll give me 10 over 6. And then in order to put this into a friendlier number than 10/6 of a foot or 10/6 feet, I'm going to make a hole that's broken into 6 equal parts. And I need a total of 10 parts. So there's 6. That's 6, 7, 8, 9, 10. So we know that Chloe's picture was 1 hole and 4/6 feet long. Page number 2. Question 1 says, there are 10 players on Kyle's soccer team. 2/5 of his team are girls. How many players are there? So if I have 10 players and I need to break, this is actually reminding me of the coin problems we did a couple of weeks ago. So I have 10 players and I need to break them into fifths. So I have 1/5, 2/5, 3/5, 4/5, 5/5. So I've got my 10 players and they're broken into fifths. So there's 2/5 of the team. That would be a total of 4 players. So 4 of the players are girls. Question number 2 says, Riley and her brother ordered a pizza with 8 slices. If they ate 1/4 of the pizza before going to play, how many slices did they eat? So here I have my pizza broken into 8 slices. They ate 1/4 of the pizza. How many slices did they eat? They ate 2 slices. Question number 3. Christy is making a cupcake for her 6 friends, or making cupcakes for her 6 friends. If 2/3 of her friends want chocolate, how many chocolate cupcakes will she make? So here are her 6 friends. I'm going to break them into thirds, or 3 equal groups. If 2/3 of her friends want chocolate, how many chocolate cupcakes will she have to make? She will need to make 4 chocolate cupcakes. And the very last problem on the bottom says 10 students in Mr. Burke's class signed up to order lunch. 1/5 of those students wanted hot lunch. How many students ordered hot lunch? So I have 10 students. I'm going to break them into 5 equal groups. So 1 group, 2 groups, 3 groups, 4 groups, 5 groups. So there are my 10 students broken into 5 groups. 1/5 of those students wanted hot lunch. So 2 students ordered hot lunch. All right. So that is our math work for today. As always, reach out if you're confused or have any questions, and I hope you have a great day.